Hey guys! Welcome back to my YouTube channel. Today I'm going to be talking about the product rule and using the product rule to find a derivative of a function. So with the product rule, we generally have a function that looks something like this, right? f of x equals g of x times h of x. So function f of x, and there's like two things that can be multiplied together within that function to give this function. So that's like a product, right? G of x times h of x, that's a product. And we are trying to find a derivative of that, okay? Using the product. So, the derivative of this, according to the product rule, right, the derivative of f of x, right, f prime of x, is basically equal to the first one, the first function, g of x, times the derivative of the second function, which is h prime of x, right? H prime of x is a derivative of h of x, and then we have to add the derivative of g of x, so g prime of x times h of x. So essentially what we have is the first function times the derivative of the other one, and then the derivative of that first function times the other one. So that is the product rule. So let's say we have an example of something like this. F of x equals 6x squared minus 21 times 2x to the exponent of 3 plus 4. So in this case, what I like to do is when I first learned this product rule, I found it very, very helpful to basically let one part of it be a function as g of x and let the other part of it be a function called h of x. So what I like to do is I like to do this. Let g of x be equal to, let's say this first one is g of x, so 6x squared minus 21, okay? And then I let my second one be my h of x, so my second one, 2 times x to the exponent of 3 plus 4 is going to be my h of x. So this is my g of x right here. And this here is my h of x. Okay, I found that very, very helpful when I first learned the product rule. So I recommend you do the same. Let this be the case, okay? And then find a derivative of each of them separately. So we have g of x and h of x. So g prime of x, which is the derivative of g of x, we basically use the power rule. So this 2 here gets taken down. So 6 times 2, right? And then this is x, and then we have to subtract the exponent by 1, so exponent of 2 minus 1 using the power rule, and we will get 12x to the exponent of 1, which is 12x. Now h prime of x, which is the derivative of h of x, we have basically to multiply this 3, right, with the 2 using the power rule. So power rule, 2 times this 3, right, bringing this 3 down, and then there's an x here, and 3 minus 1, like that, because of the power rule. So 2 times 3 gives us 6, x to the exponent of 3 minus 1. 3 minus 1 is 2, so x to the exponent of 2 right here, and thus this is our derivative of h of x. This is our derivative of g of x. So now carrying on from here, we have to find our derivative, right? So f prime of x, so f prime of x, remember, is equal to g of x times h prime of x plus g prime of x times h of x. So let's just substitute what we have. So we have g of x as written here is 6x squared minus 21, so 6x squared minus 21 is our g of x. We substitute it in right here. And then h prime of x is 6x squared as found here. So we're going to substitute that in here as well. And then plus, right, plus sign right here. Copy that. And then g prime of x, we need to substitute that, which is 12x as shown right here. So I'm going to write in 12x. And then now I substitute my h of x. h of x is 2 times x cubed plus 4. So I'm going to substitute this in. And there I have it. So now all I have to do is simplify. So simplifying this, use the distributive property, right? 6x squared times 6x squared is going to give 36x to the exponent of 4. 6x squared times -21 is going to give -126x squared. And then here, we have to use the distributive property as well. So 12x times 2x cubed is going to give 24x to the exponent of 4. Now 12x times 4 is going to give 48x. And then from here we can simplify. So we have a like term here and a like term here, both x to the exponent of 4. 36 plus 24 gives 60, so it's going to be 60x to the exponent of 4. And then we copy -126x squared, copy positive 48x. And there we have it. We have found the derivative of f of x right here. So this here, f prime of x is our derivative of the given function f of x from here. So now say we have a function that looks something like this and we are asked to find the derivative. So let's say this here is our g of x. Let's let this be our g of x. And then let's let this be our h of x. Okay, remember to find a derivative f prime of x, it's equal to g of x times h prime of x, the derivative of the second function, plus the derivative of the first one times the second one. So from here we need to find a derivative of g of x and h of x. So finding that, we have to find g prime of x. G prime of x is equal to basically the derivative of 3 times e to the exponent of x. Now the derivative of 3 times e to the exponent of x, right? The derivative of e to the exponent of x is basically e to the exponent of x. And we have basically this coefficient here multiplied to it, so it doesn't make a difference. So the derivative of 3 times e to the exponent of x, if we look at it, if we rewrite this, we would have basically 3 times the derivative of e to the exponent of x. Well, e to the exponent of x is just going to, derivative of that is just going to be e to the exponent of x itself. But I'll explain why. Because when you have like this exponential function, you would have to take the ln of the base as well, so ln e, right? And ln e is equal to 1. So it's like 1 times 3 times e to the exponent of x. So this here derivative is going to be simply 3 times e to the exponent of x times 1, which is just 3 times e to the exponent of x. So that's our g prime of x. Now for our h prime of x. So for our h prime of x, we use the power rule. And using the power rule, we can see that this is 4 times x to the exponent of half, right? So if we rewrite, let's say we want to rewrite h of x. H of x is the same as 4 times x to the exponent of half, right? The square root is exponent of half, and then minus x cubed, and then plus 2. So a derivative of this, we have to take this half down, okay? Half multiplied by 4. So it's going to be 4 times the half, just like this, okay? 4 times the half, we take it down, and then we have to write x, of course, and then we have a half, and we have to subtract 1 from the exponent using power rule. And then this is negative, we take this 3 down with the negative, so negative times 3 is going to be -3 using power rule, and then x, right, we have to write the x, and then 3 minus 1, subtract 1 from the exponents right here, and then constant here, well, the derivative of a constant is just going to be 0, so we don't write anything here. So now we have 4 times 1/2, so that's going to be 2. And then this is x to the exponent of half minus 1. Well, 1 is the same as 2 over 2. And this is -3 times x to the exponent of 2. 3 minus 1 is 2. And this is 2 times x to the exponent of half minus 2 over 2. Half minus 2 over 2. 1 minus 2 is -1, so -1 and then over 2. Then now we have minus 3x squared And this is a negative exponent, so a negative exponent means we can take this in the denominator and rewrite it as a positive exponent like that. This is minus 3x squared, and this is the same as 2 over square root of x minus 3x squared. Alright, so now we have found our h prime of x and our g prime of x. We know our g of x and h of x, so it's time to substitute it into here. F prime of x equals g of x times h prime of x plus g prime of x times h of x. Because we have basically a product, these multiply together, so we can use that. So let's use a product rule. So we have f prime of x. It's going to be equal to, first we must substitute g of x. G of x is 3 times e to the exponent of x. So writing that in right here. And then secondly, as shown here, we have h prime of x. H prime of x was found to be this expression, so I'm going to copy that expression right here. And then next we have to write in a plus sign. So I'm going to copy a plus sign right here. And then we have g prime of x. G prime of x was found to be 3 times e to the exponent of x, so I'm going to write that in right here. 3 times e to the exponent of x, right? G prime of x from here. And then now we have to sub in h of x. H of x is this expression right here, right? So it's going to be 4 times square root of x minus x cubed plus 2, so minus x cubed plus 2, just like that. Alright, and now we can just simplify it. So simplifying this, we can see that, well, how about let's factor this 3. Yeah, this 3 times e to the exponent of x. I'm going to factor that out and then simplify the rest of the stuff. So I factor this here, and I factor this here. I'm going to factor it out. So this is just going to be 2 over square root x minus 3x squared. I'm going to combine this here with this because I'm factoring 3 e to the exponent of x out, and I'm combining this part here and this part here. Okay, so I have this, and then plus, well, it's not going to change the sign, so I'm just going to copy it. 4 times square root x, that's shown here, and then minus x cubed plus 2. And then from here, I am going to recognize we have a denominator of square root x. I'm going to simplify that. So simplifying that, I'm going to basically get all of these terms to have it. So to simplify that part, I'm going to get this as 2 over square root x, right? The same thing. And here it's negative 3x squared times square root x over square root x right here, right? I multiplied this, the numerator and the denominator by square root x. Here it's plus 4 times square root x. So I'm going to multiply the numerator by square root x and the denominator by square root x. So I'm going to get 4 times square root x times another square root x. I have to multiply by square root x in the denominator, so I'm going to write square root x here, right? Because this is over 1, so I'm multiplying the square root x here, multiplying the square root x here, just like that. And then this is negative x cubed, okay, times square root x in the numerator, times square root x in the denominator, just like that. And then plus 2 times square root x times square root x in the denominator, just like that. Okay, so we can get a common denominator. Okay, it might look nicer. It doesn't really, I'm just making it look nicer from here, the derivative, just simplifying it, okay? If, let's say, your teacher isn't required to simplify it, like when you first learn derivatives, using the product rule, you don't have to simplify, but I'm just doing it just for the sake of making the final answer look nice. I know for a fact that back when I learned how to differentiate using the product rule, my teacher didn't require that we simplify it like this. She just wanted it as this step and we would get full marks, right? Because she just wanted to make sure that we know how to differentiate it properly. But for the sake of this video, just to make the answer look nice, that's why I'm simplifying it. So I'm just going to simplify this. Continue simplifying it. So here it's 3 times e to the exponent of x, and this is all with the denominator of square root x. Okay? and then this is 2, right? 2, we didn't actually change this because it already had a denominator of square root x. Here we multiply by square root x in the numerator and the denominator, so square root x here in the numerator and in the denominator. Yeah, we did it for all of these. So here we can simplify this, -3x squared, right? X squared is the same as 4 over 2, right? 4 over 2 is the same as 2. And then this is x to the exponent of half, right? Square root of x is the same as x to the exponent of half. Here it's 4 times square root of x times square root of x. Square root of x times square root of x is the same as basically x, right? Root x times root x is going to be x. This is like a half. And our half here, exponent laws, half plus half is going to give us 1. So it's x to the exponent of 1, so it's just going to be x. Here it's negative x cubed. Negative x cubed, well, it's the same as if we want to like basically rewrite as a fraction over 2. And why are we doing that? Well, just like before here, we're doing that because this square root x is a half, so we want to combine it together. So this x to the exponent of 3, we can rewrite it as 6 over 2 times x to the exponent of half. From here, this is plus 2 square root x. I'm not going to write exponent of, I'm not going to change the exponent of half, so we don't really need to combine anything using exponent laws. So now from here, 3e to the exponent of x, okay, basically times 2 minus 3. So here, x to the exponent of 4 over 2 times x to the exponent of a half. We add the exponents together according to exponent laws. 4 over 2 plus 1 over 2 gives us 5 over 2. So this is going to be the exponent of 5 over 2. And then here it's 4x, so plus 4x. And then here, x to the exponent of 6 over 2 times x to the exponent of a half. We add the exponents together and we will get x to the exponent of 7 over 2. Here it's positive 2 times square root x, and then here, denominator, which is going to be square root x, as shown right here. So now, carrying on to the next step, what we have is we can basically reorganize, put the powers in descending order, so I'm just going to do that. So I'm going to write negative x to the exponent of 7 over 2 first, then negative 3x to the exponent of 5 over 2. So here I got rid of this, and then plus 4x, get rid of this, plus 2 times square root x, plus 2 right here. This is all over root x. And then from here, we have this term have a positive at the start. We factor out the negative, so this is going to become negative 3 times e to the exponent of x. This is going to become positive then. So x is 7 over 2, factoring out the negative from each of the terms. This is going to in fact become 3. It's x to the exponent of 5 over 2, like that. And then this is going to be a different sign, negative 4x, because we have that negative, right? This negative as well. This becomes negative as well because of the negative here. So this is all over square root x, like that. And there we have it. This is our derivative of f of x from here. So the derivative of this is shown right here. Alright guys, this is the end of my video. Thank you for watching. Feel free to like, comment, and subscribe if you love this video. And I hope to see you next time for another math video. Bye!